Now, some of the easy troubleshooting steps that you might find out if you put everything back together and it doesn't turn back on, one of the main things that you can find that's pretty easy troubleshooting is in case the power cord from the power supply to the motherboard, the main power, was not plugged back in. So if that 24 pin connector that supplies the power to the motherboard isn't connected, you got some problems. And so look for that one, and you can see how it's clearly identified both on the power cord itself and the motherboard. Another one you might see that tends to happen is you might see that you forgot to put the auxiliary 4-pin power cord that provides your power to your CPU didn't get connected back together. So, look for things like that. Make sure your power cord from your cooler fan to the motherboard's been connected. If you don't hear the fan kick on, then you don't want to overheat your computer, so make sure that your fan or fans are all connected as well. Obviously, make sure to make sure that your wire leads from the front panel of your case to the front panel on the motherboard connectors, make sure those have been made. And generally those front panel connectors, those are generally color coded on your motherboard, so look for those front panel headers right there on the corner of your motherboard, and they're generally color coded as well. Take a look at your lead wires as you're making your connections too. Look at those generally 7 connectors from the front panel that connect to the motherboard and see how they're labeled. Generally they're pretty easy and they'll match up with what's on your motherboard. So it's almost dummy proof. But make sure you have the right ones plugged in. If you don't see some of the lights on the front panel of your computer when you go to turn on, that's a good indicator that you've probably either did not make the connection to the motherboard, or maybe you're like 1 pin off. Once you've made all the connections from the different components to the motherboard, from the power supply unit to the motherboard, turn on your computer, make sure that you have power, make sure that your PC is working properly. If not, generally speaking, you probably have either a loose or missed connection during your reinstall of everything into your computer. So to go ahead, shut it down properly, make sure that you unplug the power cord from the back of the power supply unit, make sure you cycle any residual power out by holding the power button in for a couple seconds, take your side off and do a good examination of the inside of your computer, compare that with the pictures or diagrams, whatever you did prior to disassembling everything. Make sure everything is back the way that it should be. If everything seems to start up right, but you notice that something that you are using a PCIe device for maybe isn't working, make sure that you checked that you plugged in the 6 or 8 pin power connector for that PCIe device. Perhaps you missed that, but the computer started up correctly for everything else. But just make sure that all your PCI connectors have been made properly too. So you might think everything starts up fine, then you might get a call from a customer later saying, hey, I have this card that I use for such and such and it's not working. So make sure you double check all of your work before leaving your customer site. Now that we've discussed that part of the chapter, let's go ahead and start talking about cooling methods and devices. One of the worst things to happen to our computers is they overheat, so we want to make sure that that doesn't happen. Now, if things start to overheat, get past those safe limits, you can see that your computer system starts to become unstable, and you don't want this to happen. And over long term, you don't want your components to fail, and you have to replace those. So make sure that cooling methods are taken advantage of. Even if you think you have a cool system, sometimes you may just want to know if the environment's going to change. Perhaps you've got computers in an environment that may be moving to a different location. You might need to make sure that you have a different type of cooling method put in place. Some of the devices used to cool a system are CPU and case fans. Now, the role of a cooler, which for your motherboard, which usually consists of a fan and a heatsink, is is really important, and they're typically made of aluminum and or copper. Now these heat sinks or these coolers, however you want to call them, take that heat away from, generally we're just going to talk about the CPU. Take the heat away from that because that's one of the components in your computer that uses the most electricity, so it's going to create the most heat. Video cards, these sometimes are intense, resource intensive, and they take a lot more power, and they're going to generate more heat. So sometimes your video cards, some of those PCIe devices, are going to have their own coolers on them to take that heat away and push it away from the component. You're also going to have case fans. You may see some computers that have two, generally about two or even up to 3 case fans to take that heat and push it away from the computer case. Generally speaking, the larger fans are often preferable to small fans in that they produce less noise and allow for a greater airflow of keeping your system cooled down. Though not often seen very much or hardly ever used are liquid cooling systems, and you can go online and look at some of these and see how they work, but essentially it's just keeping the components cooled by a flow of a cool liquid near the part, and then as that cool liquid moves around the parts, the warm is absorbed and taken away from the parts to keep those parts running good and keep them at their acceptable levels. We're also going to talk about dust preventing tools. Dust can greatly harm our PCs. As I mentioned in another session, having a can of compressed air is one of your greatest fans. You should perform some, preventive maintenance on your computers, depending on your environment, but generally speaking, perform this twice a year, where you take off the side and blow out the dust from your computer, or use a anti-static vacuum to absorb and take away all the debris that builds up in the computer. Once that debris builds up, it can cause your system to overheat. It can also jam up and make parts not work. So we want to make sure we prevent dust from hurting our computers. If you're in a really dirty environment where a lot of debris gets collected, you might want to take your preventive maintenance plan and up that to several times a year, and if it's really bad, maybe even once a month. Now, you won't see these on low-end computers, but on your higher-end computers, such as a really intensive gaming computer, or even like a CAD type workstation, you might find that you see RAM coolers or even hard drive coolers. Hopefully, as you get into the field, you'll start working more with your SSD drives, so you'll get away from the moving parts. But there are hard drive coolers and RAM coolers. You can go on sites such as Newegg.com and some of those. Just take a look, or even look at some YouTube videos to see how those RAM coolers and hard drive coolers work. I want you to see the process cooler, the fan, and the heat sink here. Now, the book tells us that there is an Intel maximum heat limit of about 185 degrees Fahrenheit or 85 degrees Celsius. So you don't want it to get that hot. You don't want your processor to get that hot. You want to make sure it stays more between the 90 degree to 110 degree Fahrenheit temperature, or if you're using Celsius, about 32 to 43 degrees Celsius. Now, how this works is the cooler itself sits on top of your processor, and this consists of a fan and then a heat sink. As you see this here, and the heat sink just uses fins that draw the heat up and away from the processor, and then your fan is going to blow that drawn heat away from your CPU unit. So your heat sink is going to allow that hot air, kind of pull that hot air up away from your processor, and then the fan is going to help take that hot air and blow it out and away from that processor that's going to continue to stay hot. Now, as I said previous, these are usually made of, the cooler is generally made of aluminum or copper, or possibly a combination of both the aluminum and copper. And these are going to be bracketed to the motherboard using a wire or plastic clip. And when you open up your case and you look at your cooler, you'll see that there's usually like a latch that you're going to lift up, and you can take this up off the motherboard. And what you're going to notice underneath, in between that and the processor, you're going to have like a cream-like material. This is a thermal compound, and that helps eliminate any type of air pockets, and it helps to draw the heat off the processor. So if you ever remove this, make sure you have thermal compound around so that you can reapply that to the surfaces to make sure that your CPU cooling is working correctly. And once you put these back together, that onto the processor, that is going to make an airtight connection between your fan and your processor. And remember that for your A+, as well as possibly other exams, that as you see in the picture, your cooler gets power from the power supply unit using a 4-pin fan header on your motherboard. So it's going to plug directly into the motherboard and get that power using that 4-pin fan header. Now here's an example of a PCI fan card that can be used next to a high-end like graphics card to help keep it cool, to help pull that air, that hot air, that heat away from that really high capacity electrical component of your graphics card, and to help keep it cool. So here's just an example of that for you to see. I want to say one more thing about dust as it concerns our computers. Not only is it important to get the dust out of the inside of the computer, it's also good to regularly get the dust off your keyboard, even your monitors. Just keep everything clean. The dust can really harm your components as it builds up, kind of creates like a blanket over things or creates jams. So as part of your regular preventive maintenance, make sure you're cleaning out the inside and the outside of the computer of any and all dust debris.